My name is Jaime Barbosa, and I will be talking about my science fair project, the effectiveness of antibacterial cleaners. In this science fair project, bacteria will be exposed to a 3-week incubation period. Following the incubation period, the bacteria will be exposed to an antibiotic solution. This exposure allows researchers to assess the solution's influence on bacterial viability and growth suppression. The 3-week time frame of this trial was chosen to account for possible differences in bacterial response over a long time frame. The findings of this extensive testing approach will give vital insights into the practical efficiency of antibacterial solutions, influencing choices on its possible uses and relevance in varied solutions. I believe that the bacteria will have a huge resistance towards the antibacterial solution, but will still reduce the amount of bacteria in the petri dishes. A 3-week incubation period is enough time for bacteria to grow in high amounts. So the antibacterial solution, when placed on the petri dishes, will reduce the high number of the bacteria in the petri dish, but it will not have an instant effect as most marketing will market it. In this experiment, I will be using a bottle of ready pour agar, bottle of recovery broth, a sterile water, petri plates, plastic micro-tipped transfer pipettes, wrapped 10 milliliter pipettes, it has to be sterile, cotton swabs, which are also sterile, disc for antibiotics, and liquid antibacterial solution. To begin this experiment, the bottle of agar must be melted before starting the project. You must place the bottle of agar inside a pot of boiling water. Make sure to replace any evaporated water. Step 2. After the agar is melted, gather these materials: sterile water, transfer pipettes, wrapped pipette, and cotton swabs. You will then use the two transfer pipettes, one to collect 5 milliliters of sterile water and the other one to collect 5 milliliters of agar. Transfer both of these solutions into a wrapped pipette and shake to mix the solutions. After mixing, you will place a solution into 3 petri dishes and allow solution to cool for 10 minutes. After cooling, use cotton swabs to 3 different bacterial samples and gently smear the petri dishes with the collected bacterial samples and incubate for 1 to 3 weeks to allow the bacteria to grow. After incubation period, you will need a liquid antibacterial solution. Using a transfer pipette, you will get 5 milliliters of antibacterial solution and place inside each petri dish, 5 milliliters each dish. Allow incubation time for 10 minutes. Examine for any bacterial losses or death. A little background of this experiment. Scientists and researchers have been coming up with new and better drugs to cure bacterial diseases. However, as antibiotics grow increasingly significant in medicine, antibiotic resistance becomes more widespread. When a doctor finds an infection, they need to make a decision on the course of treatment. Today, doctors have a consistent treatment plan for most diseases. These recommended treatment regimens came from researching testing demonstrating which antibiotics certain microorganisms were most sensitive to. One typical way for scientists to examine the effectiveness of an antibiotic is the particular sickness using the Kirby bar disc diffusion experiment. This experiment uses antibiotic containing discs to measure the sensitivity of bacteria to antibiotics by culturing bacteria on a plate and placing the soaked discs on the bacteria. Health practices, policies, and the effects they have on society are frequently studied as a part of social studies. By researching how antibacterial cleansers work to stop the spread of illnesses and diseases and how this impacts general population health, research on antibacterial cleansers connect to public health. The investigation of governmental policies and laws is a component of social studies. It is interesting to study how regulatory organizations like the FDA evaluate and approve antibacterial cleansers. Social studies are responsible for explaining how these laws are created, implemented, and how they affect public safety. Majority of scientific research, including studies of efficiency of antibacterial cleansers, is documented in English. To reach a larger audience, researchers present their results, methodology, and conclusions through reports and publications written in English. English is the language that scientists and researchers use to present their discoveries in conferences, seminars, and scholarly journals in order to disseminate discoveries and interact with the scientific community. Communication must be effective. In this project, I studied the effect of a liquid antibacterial solution on 3-week incubated bacteria. I predicted that the bacteria will have good resistance towards the solution but will not last long after exposure. Mixture of 5 milliliters of agar and 5 milliliters of sterile water allowed for a sterile foundation for the bacteria to grow. I gathered bacterial samples from a door handle, chicken broth, and dog water. Each bacteria had a different level of growth or concentration of bacteria. When adding the antibacterial solution to the petri dishes, there was a slight effect on the bacteria. Bacteria started to move away from the solution and started to shrink at a slow rate. After a 10-minute incubation period, the bacteria has shrunk half of its original size and got the color blue from the antibacterial solution. Most of the bacteria in each of the petri dishes are gone, but big clumps of bacteria seem to keep intact. After allowing the 1 day of incubation, the remaining bacteria seems to have developed immunity against the solution as it has not decreased in size. I have two pictures here. On the left, we can see the 10-minute incubation of the door handle bacteria, chicken broth bacteria, and dog water bacteria. As you can see, there was slight clumps in the chicken broth bacteria. In the door handle bacteria, most of the bacteria died in that 10-minute incubation period with the antibacterial solution, but there was still small clumps of bacteria. In the dog water, it just moved away from the solution, and the solution and the bacteria just kind of separated. As you can see, there's one side that's blue and the other one clear as day. And then on the right side, we have the 1 day incubation period. The door handle seems to not have any more clumps of bacteria, but there were still some slight dots. In the dog water bacteria, the bacteria has completely moved to the opposite side, leaving the solution just alone on the other. There was no decrease after the 10-minute incubation period. And then the broth only had one huge clump and multiple dots, but the solution seems to go around the petri dish, not directly on the on the bacteria. Thank you for watching.